Now we look for the COP that follows the law of PV raised power n equals to what? C, right? That is the polytropic process. Now what we'll do is the work done by the compressor during the polytropic process or during the process 1 to 2. So work done by compressor during the process 1 to 2 per kilogram of air. Now this is the compressor here, right? The work done is in between state 1 and state 2. So when you move from one state to another is process 1 to 2. So that will be W1 to 2 is equals to, so the work done in a polytropic process is giving us n over n minus 1 into brackets P2 V2 minus P1 V1, right? So it is the high pressure side minus the low pressure side. That is, so this is the high pressure side. 2 and 3 at the high pressure side, 1 and 4 at low pressure side. So it will be high pressure side minus what? Low pressure side. Now, but pressure times volume is equal to what? The gas constant arrow times what? Temperature. It's a relationship we should know. So anywhere I see PV, I'm going to put ROT. So RO is a what? A gas constant. So I will now be having the W1 to 2 to be equals to n all over n minus 1 into bracket. So instead of this, I'll put in ROT2 minus ROT1. I'm not attaching any subscript to the arrow because it is a constant, right? So if I want to rewrite this now, I will now write that my W12 or W1 to 2 is equals to n all over n minus 1. I'll bring the arrow out into bracket T2 minus what? T1. So this is work undergoing during process 1 to 2. Now the work done by the expander, this is the work done by the compressor. The next one will be, I'll call this my equation 1. So this is the work done by the expander. So the work done by the expander during process 3 to 4. Work done by the expander during process 3 to 4 per kilogram of air per kg of air, right? So what you do is look at the expander here. This is the expander here. The work done during process 3 to 4, that is from state 1 to state 4. It will be the high pressure side minus low pressure side. So it will be W 3 to 4 equals to what? N all over n minus 1 into brackets P3 V3 minus what? P4 V4. So but PV is equals to what? RT. As from there we write this equation by saying that the work done between the expander is equals to n over n minus 1 into brackets RT3 minus RT4. So my work done between state 3 and 4 will be n minus 1. Bring the arrow out because it's common. So we'll be having T3 minus what? T4. I'll call it my equation what? Equation 2. So from this case here, we will know very well that the COP or the work done by this. Hence, the total work done, so the net work done will be the work done by the compressor minus the work done by the expander, right? So this is the work done by the compressor minus the work done by the expander. And what is the work done by the compressor? The net work done. What is the work done by the compressor? The work done by the compressor is given as what? N over N minus 1 into bracket RT2 minus RT1. So N all over what? N minus 1 into brackets R brackets T1 minus what? T2. Right? T2 minus T1, sorry. T2 minus what? T1. That is the work done there. Minus the work done by the expander. The work done by the expander is what we have here, and that will give me N all over N minus 1 into brackets N bracket N minus 1 into brackets T3 minus T4. Then I can write my arrow here, I write my arrow here, nothing changes, into bracket arrow. Now if you look at both of them, what is common? My N all over N minus 1 multiplied by arrow I have in both sides. So open the brackets, I'll be having T2 minus T1 minus T3 minus T4. So I'll factorize it now. Arrow is here, I brought it out. N over N minus 1 is here, N over N minus 1, I brought it out. So we'll be having this as our network done here. And we know very well that this is equation 3, and call it that way. So we know very well that COP, quotient of performance, is equal to what? The desired effect, over what? Work done. Right? Work done. So we'll be having what our desired effect is the cooling, and desired effect happens at the refrigerator, which is here, right? And that is between state 4 and 1. So we have T1 minus T4. So we're going to look for that aspect. So to be CP, that will be at that state 4 and 1. So to be heat absorbed, all over what? The work done. So from here, my heat absorbed is given as CP into brackets CP into brackets T1 minus T4. T1 minus T4 all over what? The work done. What is the work done? This is about equation 3 is the work done that we're using. So we're having N over N minus 1 times R, open brackets. We have T2 minus T1 minus T3 minus T4. I close the bracket. Alright, so from here, recall recall that the arrow is equal to what? CP minus CV, which is also equals to what? CV into bracket gamma minus 1. So anywhere I see arrow, I'll put CV into bracket gamma minus 1. So this will now give us CP into bracket T1 minus T4 all over n minus 1 multiplied by, instead of me putting my arrow, I'm going to put CV into bracket gamma minus 1. Right? So into bracket T2 minus T1 minus T3 minus T4. I close the bracket back. So from here, in recall, CP over CV is giving us the gamma. So when I'm to write this back, I'll be having gamma into brackets T1 minus T4 all over n minus 1 multiplied by gamma minus 1 because to remaining this, open bracket T2 minus T1 minus T3 minus T4. I close the bracket here. So from here, I can move forward. If I bring this guy downward, I'm going to be having T1 minus T4 all over n minus 1. Bring it down, multiplied by gamma minus 1 over what? Gamma into bracket T2 minus T1 minus T3 minus T4. I close the bracket back. So from here, this is our COP when it follows the law of polytropic process, when it follows the law of what? P raised power n equals to C, right? Example 2 says that a refrigerator working in a COLEMAN cycle operates between pressure limit of 1.05 bar and 8.5 bar. Air is drawn from the cold chamber at 10 degrees centigrade, compressed and then cooled at 30 degrees centigrade before entering the expansion cylinder. Full stop. The expansion and the compression follows the law PV raised power 1.3 is equals to C, determining the theoretical COP of the system. Now, since it is following the polytropic process, our COP will now be, the COP will now be T1 minus T4 all over n minus 1 multiplied by gamma minus 1 over gamma into bracket T2 minus T1 minus T3 minus T4. So this will be the COP we'll be using because of what? It is a polytropic process. So write out our parameters, the data given. Now another most important thing is that what? We must always draw a graph, this graph here, to help us in doing what we want to do. So it says that what? Let's see. It says a refrigerator working in a COLEMAN cycle operates between the pressure limits of 1 bar and 1.0 bar and 8.5 bar. So the pressure limit is in between P2 and P1, abi. So we say P3 equals to P2 is a high pressure point, and P1 is equals to P4 is a low pressure point. So we say P2 is equals to P3, and that will be the high side, 8.5 bar, and P1 equals to what? P4 is equals to 1.05 bar. Now move forward. Say air is drawn from the cold chamber. Now if you look at this, what's the cold chamber? The cold chamber is refrigerator, and when air is drawn, that is at state 1. That's when air is drawn, that is T1. So at 10 degrees, so my T1 is equals to what? 10 degrees centigrade. If you convert it into Kelvin, it will be 273 plus 10, and that will give me 283 Kelvin. Now, compressed and then cooled at 30 degrees Celsius before entering the expansion valve. Now it is compressed and then cooled at 30 degrees Celsius before it enters. So T2 is equals to what? 30. If you look at it very well, it is cooled. Read the question very well. Compressed and then cooled at 30 degrees before entering. So before entering the expansion valve, it has 3 here. But this is the expansion valve here. So when it is cooled, after being cooled, it's at state 3 before entering the expansion valve. So that will be T3. So T3 will give me 30 degrees Celsius. If you convert it into Kelvin, it will be 273 plus 30. And that will give me what? 303 Kelvin. Now we push forward. Before entering the expansion valve, the expansion cylinder, the expansion and compression follows the law of PVN. So we know that from this law here that says PVN equals to C, and it is similar to what? PV 1.3 equals to C. So we know our N here, our index is 1.3, right? So now with all this, we've gotten T1, we have T3, so look for what? T2 and T4. So T2 and what is what we're looking for, and T4. So let's start solving for that. Calculating for T2. Now we'll use this relationship that says that P2 over P1 raised to the power. Since it is a polytropic process, I will not use gamma, I'll be using n minus 1 over n, right? Equals to what? T2 over what? T1. Now, what is my P2? It's 8.5 all over P1 is 1.05. Raised to the power, what is the n? N is what? 1.3 minus 1 over 1.3 equals to the T2 is not given over what? The T1 is given to be what? 283, right? So if I cross multiply or I continue working this way, I'll be having 8.05 divided by 1.05. I'll be having 8.05 divided by 1. Yes, 8.5 divided by 1.05. That is 8.095. So we have 8.095 raised to the power of 1.3 divided minus 1 will give you 0.3. 0.3 divided by 1.3. Or let me just put this way: 0.3 all over 1.3 equals to T2 over 283. So if you divide 0.3 divided by 1.3, 0.3 divided by 1.3, I'll be having 0.2307. So I'll have 8.095 e to the power of 0.2308 equals to T2 over 283. So if I have from here 8.095 raised to the power of 0.2308, I'm having 1.6204 equals to what? T2 all over 283. Now I will cross multiply. So my T2 will be giving me 1.6204 multiplied by 283. So T2 will now give me multiplied by 283. So we'll be having 458.57 Kelvin. This is my T2 here, right? So the next we'll do, we're calculating for what? We've gotten T2 now, we'll need T4. So calculating for T4, let's move forward. So calculating for T4, so use the same relationship. This is high pressure side P3 over low pressure side P4 raised to the power of n minus 1 over n equals to what? T3 over what? T4. So I'm looking for T4. Now from here I can just proceed. My P3 is given as 8.50 bar. P3 here 8.0 bar, 8.5 bar, sorry. So I have 8.5 all over P4 giving us 1.05 also raised to the power of n minus n, that is 1.3 minus 1 all over what? 1.3 equals to T3. T3 is given as 30, 63 is given as 303 Kelvin. So I have 303 over what? T4. Is that okay? So from here, if I work with this, we've done it here. We have 8.5 divided by 1.05 is giving me 8.095. So I'm going to put 8.095 here. Raised to the power of this, what I have here, and that is this will give me 0.2308. So I have 0.2308 equals to 303 over T4. So if you divide this, we're going to be having 1.6204. So 1.6204 will now be equals to 303 all over T4. So if I take T4 to this side, I'll bring 1.6204 to this side. So that will now give me T4 equals to 303 all over 1.6204, which will now give me, let's do that here, to have 303 divided by 1.6204. So So we have 186.99. We have 186.99 Kelvin. That is my T4. Right? So from here, we can now say that we'll put all this value into the COP. So let me do it here. Put the value into the COP equals to T1 minus T4 all over N minus 1 multiplied by gamma minus 1 over gamma. Opening the bracket, we have N T2 minus T1, close it, minus T3 minus T4. So this will now give me this. So let's put in our value. We know that T1 is giving us 283. Look at it very well. T1 is giving us 283. We put it here. We have 283 minus T4, which we just got here now, 186. That gives me 186.99 all over N giving us 1.3 from our parameters. N is 1.3. N giving us 1.3 all over 1.3 minus 1 multiplied by our gamma is a constant in terms of isentropic process, and that's giving us what? 1.4 minus 1 all over 1.4. Open the bracket. So we have T2. T2 is giving us, this is the T2 here, 458.57. We have 458.57 minus T1 is giving us 283 also, 283. Close the bracket, minus T3 is giving us 303 is given. T3 is giving us 303, and we put it here now, right? So 303 minus T4 is giving us 186.99. So we have 186.99. So from here, if you subtract 283 minus 186.99, 283 minus 186.99, I'm having 6.01. So that means we're having C.O.P is equals to 96.01 all over. Now from this point, 1.3 divided by 0.3. So we have 1.3 divided by 0.3, 4.33 to 1.3. 1.3 minus 1 will give 0.3. So when we divide them, we're having 4.33 multiplied by 1.4 minus 1 is 0.4. So 0.4 divided by 1.4. Now having 0.2857. 0.2857. So into brackets, if you subtract 458.57 minus 283, you will get 175.57 minus, you subtract 303 minus 186.99, you get 116.01. Now this will now give us 96.01. If you multiply 4.33 times 0.2857, 4.33 times 0.2857, we're going to have 1.237. So this will give us 1.237 multiplied by, if you subtract 175.57 minus 116.01, you have 59.56. So if you move forward, the COP will be 96.01 all over 1.23 multiplied by 59.56. So that gives me 73.68. So we have 73.68. So therefore, the COP will give me 96.01 divided by 73.68. That'll give me 1.303. So 1.303. So that will be my COP. Thanks for watching. We'll meet in our next video.